Okay guys, so we have a very interesting problem here. The beaker ball balance problem. So what we're going to do is we're going to understand why this side tilts. So let's first discuss this system. Both of these balls, they both have the same volume V, and both of these liquids are same, and let's just say they both have a mass of M. And as you can see in this beaker, the ball is trying to float, but it's attached by a string to the water. And in this beaker, the ball is hanging within the liquid, immersed by a string. So, to understand how one side tilts, we need to analyze both of these systems separately. So first, let's analyze the system A. So, what you can see here is that the ball is trying to float within the liquid, but it's attached by a string. So, from there will be a force preventing the ball from floating upwards. That force is the tension, and this same tension will act on the beaker because of the string. And since this ball is immersed in the liquid, there will be an upthrust on the ball by the liquid, and also the ball will have a certain mass. Let's say it's m1, and it will have a certain weight. But you see, what we actually need to understand is what are the forces acting on the balance by this system. So you can see that this tension will act at this point, but I'm going to mark it here on this balance. See, because both these surfaces are in contact, and the Newton's third law pair will transfer to this surface. So this tension will act on the balanced surface. And also, the Newton's third law pair of this upthrust will act on the water from this ball, and it will act at the same position, but I'm going to mark it here as U. And this U will act on this balanced surface because it's a force, and it will act, it will travel along this direction and act on this surface. And also, this liquid has a mass, which is M. So that mass will create a weight on this surface. So all these forces will be acting on this balanced surface. So now we can write two equations. This ball is stationary with respect to this beaker. So the equilibrium equations for the ball would be U minus m1g minus t equal to 0. And what happens to the balance is the balance would move. So let's just say force, total force W1, I'm going to mark it downwards, acts on this surface. So W1 would be equal to U plus mg minus t, and we can substitute t from this equation to this one. So W1 will be equal to U plus mg minus t is equal to U minus m1g. And simplifying this, we get W1 is equal to capital Mg plus simple m1g. And I'm going to call it equation A. So we have the weight that acts on this side of the balanced surface. Now we need to understand the force that acts on this surface of the balance. So what we have here is a ball immersed in a liquid and it's hanging from a string. And since this is immersed in the liquid, it will have an upthrust similar to the earlier system, and the upthrust will be the same upthrust since it's the same liquid with the same density and a ball with the same volume. And this will have weight, but these two have different densities. This has a density dA, this has a density dB, and dA is less than dB. So this is how we arrange the system. And this weight, let's call it M2G, left over here. And similarly to this system, this upthrust will create a reaction upthrust. It will act at this point. I'm just going to mark it here. And that upthrust, it's a force. It will act on this surface as well. And this liquid is the same liquid with the same volume, so the same mass as the earlier system will act on this surface. So if the total weight, let's call it W2 acting on this system, then W2, we can write W2 as U plus mg. So that would be equation B. So we have the two weights that act on the two sides of the surface. So what we need to do now is understand what's the difference between these two forces. You can see that mg is same for both, the same magnitude, but the difference is here it's U and here it's m1g. And how do we compare these two forces? So look at this system. In this system, both the upthrusts are same in both systems, but in this system, the mass of the object is m1 and the weight is m1g. But this ball is held stationary due to a string and an extra force of tension. So as you can see, this upthrust is greater than m1g, which is why it's trying to move upwards, but it's held down by tension. So from this system, we can conclude that the upthrust is greater than m1g. And by adding capital Mg to both sides. So you can see that this quantity here is W2 and this is W. And so we can replace these as W2 and W1. So we have the result that we need. You see, now we know why this side tilts. It's because this force acting on this surface of the balance is greater than this force. And about this pivot point, this force creates a torque and this creates a torque as well. And the torque created by this side is greater than the torque created by this side. So that is why this tilts. And there you go. We have the mathematical explanation as to why it happens.